12 advanced 5.1 end of term 2. So starting by 5.1.2, relating E to HF and HC over lambda and doing this conversion. So from EV to joules, I will multiply, and from joules to EV, I will divide. But when I divide, I have to make sure that I put brackets. So which graph best represents the relationship between the energy of a photon and the wavelength? So it is E equals to HC over lambda. So these are constants and these two are inversely proportional, so B. Actually, A works for E equals to HF, which is this one. Never mind. What determines the energy of a photon, not the velocity? It is the frequency, because it is HF. So the frequency. Which of the following will decrease the energy of a photon? So to decrease the energy of a photon, I have to either decrease the frequency, so this one, or also to decrease the energy, I have to increase the wavelength. So 1 and 5. 1 and 4, ما في 5. How to calculate the energy in EV of a photon of a frequency this much? I've got the frequency. So E equals to HF. However, when I'm using H, my answer will be in joules. Here I need to have it in EV, so I must convert by dividing by 1.610 to the power of negative 19. So 610 to the power of negative 34. The frequency is 5. And because I need to have it in EV, I have to divide by 1.6 times 10 to the power of negative 19. So the answer is 2.1 eV. Now calculate the wavelength of a photon. I have it as in form of an energy. Pay attention, this is a question from the focused list. So I have the energy, I need the wavelength. So here no need to convert anything. HC over lambda. So the energy is in joules, very good. 144, 10 to the power of negative 19. H and the value 6.63 times 10 to the power of negative 34. C is also a constant, 3 10 to the power of 8. And lambda will be in meters. So it is 1.38 times 10 to the power of negative 6 meters. Now we need the energy in EV, another question. The energy in EV of a photon that has a wavelength of this much. Hala, not to forget that I need to also to multiply by 10 to the power of negative 9. Now the energy that I will have, because I'm using H, I will have it in joules. So it is 6.63 times 10 to the power of negative 34 times 3 10 to the power of 8 divided by 620. Nano means 10 to the power of negative 9. Okay, now I will receive it as energy in joules. How can I convert it? Simply this energy, this 3. So from joules to EV, I have to divide. Okay, so this energy, هيدي الانرجي يلي طلعت لي هلا, energy equals to 3.2 times 10 to the power of negative 19. I will divide it by 1.6, 10 to the power of negative 19. So I'll have 2 The unit is in EV. Continuing with 5.1, which of the following statement about the ground state and excited state of an atom is correct? So the ground state has the highest energy while excited have lower? No, this one has the least energy. In the ground states, electrons occupy the highest energy levels, the lowest energy level. The ground state corresponds to the lowest energy configuration. I like it. The ground state and excited, they have the same. Not really. Now let's continue. So I'll call it A, B, C, and D. Electrons in an atom can only have specific energies. These energies are called electron energy levels. So I'll put here C. Normally, electrons occupy they are in the lowest energy level available. This is known as down. It is the ground state. So this one has the lowest energy level. Electrons can gain energy and move up. This means they are absorbing, not releasing. And eventually, how can electron move up an energy level? They need to absorb. They will absorb it either by collision, either by not releasing photon. They have to absorb photon, not by radioactive decay. Also, they will release photon. So these are almost the same. Absorbing a photon, they are taking energy and physical source such as heat. Continuing with 5.1, which of the statement is correct definition of excitation of electron? This means when an electron is given enough energy to move up, but not enough to leave. Which of the statement is the correct definition of excitation? Excitation is not ionization. So if it leaves, it will become ionization. So I'll take C. Which of the following statement about the ground state and excited state? So the ground state, we agreed that it has the lowest energy level. And that continuing with 5.1, here we have the energy levels of an atom is shown, which transition will emit. This means you need to go down first. Emit the photon with the shortest wavelength. So these are the two conditions. You need to go down, not to go up. And the shortest wavelength. Shortest wavelength, let me see how the energy is. So energy equals to hc over lambda. In order that this one is the shortest, the energy here should be the greatest. And I can see that all of them, they are emission because they're all going down. 4 to 1, 2 to 1, 3 to 2, 4 to 3. I have no problem with emission. But, so I have 4 to 1, 2 to 1, 3 to 2, and 4 to 3. So I can see that this one has the largest energy, 4 to 1. Later, if an atom changing from energy to energy, so this is the energy final and energy initial. So the change in energy is nothing else than the difference. So no problem here. I can take the absolute value minus 0 point final minus the initial. So E final minus E initial, which will give me 0.31 eV. Finally, 5.1. The diagram below shows the energy levels of a mercury atom, which is a transition of a photon with the longest wavelength. So again, energy is hc over lambda. Longest wavelength means the smallest energy. And I can see that this one is the smallest energy, so I'll take D. That's it for 5.1.